Hi everyone, we're going to look at rate of reaction. Rate is just a way to say speed of reaction, so how fast a reaction is happening. It can go very fast, for example, you have explosions, or you have slow reactions, for example, you have rusting, so it can take several days to happen, or it can take months to happen. So these are slow reactions. So instead of using the word speed, we're going to use the word rate. Now, you should be able to describe the effect of concentration, pressure, surface area, temperature, and catalyst on rate of reactions. So let's see. There are several factors that affect the rate of a reaction, the speed of a reaction. These are the 5 factors, right? Concentration and pressure. Concentration and pressure, these are both looking at how many particles of the reactant we have in a certain area. So for example, here you have high concentration because you have many particles in an area, and here you have low concentration, you have smaller number of particles in an area. So the more particles you have in an area, the more a reaction you're going to have, because for a reaction to take place, the particles need to come together. They need to collide with each other. So here you have less particles, less collisions. Here you have more particles, more collision. When we are talking about solution, we talk about concentration. When we talk about gases, we talk about pressure. So both of these relate to number of particles per unit area. Then we have temperature, surface area. Surface area refers to the size of the solid reactants. So you can have big chunks like a rock, right? So chunks. Or you can have small pieces which are in the powder form. So these are surface area. And then you have the use of a catalyst. We've seen catalyst in the previous topic. Catalyst is something that increases the rate of a reaction, makes the reaction faster, but itself is not used up in the reaction. So you have a catalyst. And if you remember, a catalyst, it reduces activation energy. Normally, when you're doing a reaction, we want the highest rate possible. Highest rate means faster production, and faster production means you have a more efficient and sustainable process. So if you are making, for example, ammonia gas through the Haber process, you want something that gives you the most ammonia gas in the least amount of time. This is efficient and sustainable. So factors. So when temperature increases, rate increases. So if you heat, rate increases. If you cool, temperature decreases, rate decreases. So this is direct relationship. Temperature affects rate directly. I'm going to put it that way rather. So rate is directly affected by temperature. Temperature goes up, rate goes up. Concentration, if you use a more concentrated solution, rate increases. If you use a lower concentration, rate decreases. So same thing, rate here is directly proportional to concentration of a solution. When we talk about pressure, we are referring to gases. For a gas, you can increase amount of gas. For now, you see number of moles here. Let's just say it is amount of gas. Right? So if you have more gas, you have an increase in rate. So you have more particles per unit area. So rate again is directly proportional to pressure. More gas means faster reaction. Less gas, it means slower reaction. Now particle size, when the particle gets bigger, so here particle is bigger. This is the area that is available for reaction to take place. So this is the area where particles can collide. Now if I take smaller particles, well, the total area will be the same, but I'm having smaller particles. The area of contact here, area of contact increases. So large surface, so if you have this here over here, this is small surface of contact. So this is a big particle, but it has small surface of contact. These are small particles, but they have larger area of contact. You can see the blue part. So there's more area of contact. There's more contact area. This over here should be surface area, not particle size. So when surface area increases, so this is where surface area increases, you have smaller pieces of the solid, you have high rate. Okay? When surface area decreases, this is small surface area, we have larger chunks, larger pieces, rate decreases. So here, rate is directly proportional to surface area. But if you look in terms of size of particles, rate is inversely proportional to size of particles. So when you have a big particle, speed decreases. When you have a small particle, speed increases. So normally powder form gives high rate, high speed of reaction. If you take big particles like lumps and chunks, these will give you a slower rate, slower speed. A catalyst, the simple presence of a catalyst will increase the rate of a reaction. Now we have to be very careful that the rate does not affect how much product we get. It only affects how fast we get the product. Only the speed. It does not affect how much we get. So I'll take an example. So at high concentration, you can see that. So here you have reached the maximum product. Maximum product, here you can see that the graph in pink. Higher concentration, you've reached the maximum product in less time. Compared to here, it took more time. So time 1, time 2. Here, it took more time to finish the reaction. Okay? So lower concentration, you can see that the graph is lower. So it takes more time for the reaction to be complete. High concentration, it takes less time for the reaction to be complete. Here we have another graph. This is surface area. Surface area means how big the particle is. So high surface area means powder. So it's small particle size. So small particle size. Here this is big particle size. Big particle size. Big particle size means it has smaller area of contact, like we said here. Big particle, small area of contact. Small particle, large area of contact. So when you have large area of contact, there's more chance of collisions of particles. There's more chance for a reaction to happen. So the reaction finishes already. Let's say this is 5, 10, 15, 20, 25. So already after 25 seconds, the reaction is over, while the other one is going to take around 38 seconds to be over. So large surface area. Large surface area means big particles. Big particles take more time to finish. So more time required, rate is lower. Here we have temperature. High temperature, you can see the particles have more energy, so they collide. Reaction is already over here. T1, reaction is over. And for the green graph, reaction is over at T2. So T2 is greater than T1. Reaction is over very quickly.